Let's get started. Got it. Okay. Sorry for the delay, everybody. So, yeah. Today's presentation is going to be on Zig and Elixir. Now, Zig and Elixir. So I first came to learn about Zig when my manager told me, you know, there's this interesting thing out there called Ziggler, which allows you to write NIFs right inside your Elixir module. And so we're going to get into Ziggler a little bit more later on. But one of the things I've always found fascinating about Elixir is that most people who want to do Elixir tend to want to have another language to go along with it. There always seems to be more universal. Like when I was doing .NET, nobody in .NET really looked forward to kind of using some other language to do certain things with. And I think part of that might be that the Beam is an all-encompassing machine all of its own. Elixir is really optimized for concurrency, kind of functional type programming, but there's a general sense that there's some things it's not very good at. Once again, the Beam's its own virtual machine, so if you need to go outside of that, it can be awfully hard to interact with hardware devices. We got Jordan right here. We worked together at CK building kiosks. There was times we had to go outside the Beam to interface with hardware issues or hardware devices and things like that. And yeah, so it seems to be a pretty popular thing. I mean, whenever you talk to an Elixir programmer, there's odds are they've been looking at Rust. They probably know some C. Just, you know, out of curiosity, they've kind of looked at this language or that language to kind of get in a chance to exercise their brain a little bit on how they're going to handle something that wouldn't take place in the Beam. So the main reasons why you might be interested in learning another language outside of Elixir to work with Elixir is hardware interfaces, as I mentioned. Interfacing with native libraries. There's a lot of good C libraries out there, whatnot, that take care of things that it's easier actually just to interface with them to try to read code yourself. And of course, speed. Elixir is optimized for concurrency and not at all really optimized for speed, although they do pretty good at that nonetheless. So going outside the Beam, there are three main ways we can go outside the Beam. There's ports, which is basically spinning up another OS program and kind of hooking it together with your Elixir thing through a pipe. By and large, if you need to go outside the Beam, this should be your first choice. They're fantastic. They give you supervision for very low cost. And then the OS stuff works. I mean, it feels a little clunky at first, but once you're up and running, you kind of tend to forget about it because it just works. Java and C nodes. I believe at CK we did a Java node for one of our devices.
Interface.
Yeah, the J interface thing, and it kind of worked. It works pretty good. It certainly had its own little hassles to it, but essentially that what it does is spin up something that kind of acts like another distributed C node that allows you to just pass messages between your main program and it. And then finally, you have NIFs, and that's what the bulk of our talk is going to be about here. So first, ports. Elixir has ports module. There's a thin wrapper around Erlang ports. You get supervision for very low cost. I was almost tempted to put free, but the reality is you have to put a little work into it. But it's not a whole lot, and then it just magically works through standard in and standard out. You get messages for the things, you parse them. Yeah, life's pretty good, and they work really well. Definitely the first choice. Java and C nodes, they'll create a program that looks like a distributed Erlang node. CK's bill acceptor used a Java node, worked well, but wasn't the simplest to maintain. And then NIFs. NIFs will crash the Beam, and NIFs will make the Beam unstable. This is a very true fact. I have not actually experienced NIFs making the Beam unstable yet because I did not actually create something that would actually just continually running and never yield. However, while just sort of learning how this all works, I crashed the Beam many a times. And you don't understand how used to you are like being dumped down into a console where you can like, oh, what's going on? I'm going to trace around. No, you're just boom, you're looking at the command line prompt going, well, that was unpleasant. I mean, it's just done. But they're not all bad. NIFs are very fast, and they have all the other type of things I mentioned. They really do seamlessly fit into Elixir. I mean, you just basically create a function that is just call it from a module like anything else. So Zig is a newer programming language. It's not even at 1.0 yet. It feels like that at times. We're not going to go into too much of the nitty-gritty details because overly technical things tend to get really boring. So where you want to find more info is the Zig homepage. Just do a search for Zig Lang. I'll take you right there. Another great one is ziglearn.com, which has kind of a patterns and practices kind of overview that can give you everything. And then the final place is Ziglings, which is a repo you can download that you run, and it will take you of a show where, you know, the program will start to compile, and there'll be an error, and there'll be a little direction there. So it's kind of a general introduction to how to introduce some of the language features and whatnot. A fantastic little concept that I enjoyed. So why they like Zig. This is an explanation of why the people who make Zig and whatnot promote what they like about Zig. Number one is it's simple and compact. It's manual memory management. So in other words, there's no garbage collection. There's no automatically generate things. If you're allocating memory, you're going to know you're allocating memory. No hidden control flow. This is something that kind of hyped in such a way I thought they've probably been bit by something in the past. But basically no properties, no hidden function calls. You know, if you see it, it's doing something. And stack traces on all targets. So no matter what target you're targeting for your thing, you're going to get a stack trace. And it is designed to compete directly with C. So there's no foreign function interface, can produce C compatible binaries. It certainly interfaces with C seamlessly, or pretty close to seamlessly, as we'll be going into. And the main creator basically said his goal is to replace C. Now, we all know that's not going to happen, but nonetheless, it is a kind of an interesting thing. Now, when I've been looking at it, these are the things that I find interesting about Zig. I didn't have it up here, but really they kind of just take C and try to take some of the foot guns out of it. So you're not shooting yourself in the foot so much. So one of the interesting things here is errors is a first-class concept. Optionals instead of nulls. There is a defer statement and the use of allocators. So instead of just reaching for calloc or malloc, you actually kind of pass around a struct or a function that will allocate the memory for you. One of the more interesting ones is the arena allocator, where you allocate, and at the end of the program, or at the end of your run or whatever, you just tell that arena allocator to be in it, and then everything it allocated will be freed. And then there's this concept that you really kind of push, which is comp time, which is the way the program runs at compile time. They pushed it a lot. It certainly is interesting. It's kind of how they get generics. The compile time, they'll like, hey, there's certain things you can say that during the compilation, it'll actually run the code it's compiling at thing, and, you know, filter out by type, or maybe create a function with that type signature or something like that. So first things, Zig errors. This is the part that I actually kind of love. You just can't ignore a potential error. And this is what you'll see right there. If you like try to open a file and you're not trying to deal with the error, it's going to say, hey, boom, the error is discarded. You have to either use try, catch, or if. Now, at first blush, if you've ever dealt with a language that makes you forced to deal with errors, you're going to be like, oh, this is a great idea in theory, but in practice, it's a pain in the ass, and I don't want to deal with it. I think Zig has really kind of dialed something in here, to be honest with you. Zig errors, the two main methods of dealing with them are try and catch, but they're not what you think. They don't work together. You know, we're used to having a try followed by a catch. In this case, you're either going to try or you're going to catch. Yes, exactly. Yes. So here's that same example, except here we're using a catch. So you try to open the file, you're going to catch the error if it happens. This is called, oh, what's the word for it? It's not a pattern match. It is not a binding. It'll come to me in a minute, but essentially it unwraps a value that is there. So this becomes the error value, gives it a variable. And then now we can print out, hey, we're not able to open the file. We're going to write that out standard error. And then, you know, we're execution continues file, write all, catch. If that goes wrong, then we're just going to return no error, whatever. So as you can see, it compiles fine, it runs. If we get an error opening, it just says, hey, file not found. Now onto the try, or you can pass it up the chain. And this is the one that makes the most sense to me. So right here, when you put a bang in front of a return value, that means you're going to return, in this case, a void, nothing, or an error. And you can just do your file try. And what that try means is if this returns an error, we're just going to return. We're going to return the error right away. This is that defer I talked about, defer file closed. Now that means that at the end of this block that's going to run, the file will automatically closed. That takes away one of the big foot guns of C right there. You can allocate your resource and deallocate it right together. These things. And then we have a final try write all your code bases are belong to us. And when you return it, you get run it, you go, hey, error file not found. And then you get a stack trace. Now, the interesting thing here is this is not a stack trace like we think of with try and catch. This is actually an error stack trace. So this is not constructed here before the file runs, but if the error gets run, as it's walking back up, that's when the stack trace gets built. So it's not there's no runtime performance hit for doing a try or anything like that. You only get hit with the stack trace once the error actually happens. In a lot of ways, this also to me kind of felt like that railroad track programming type in a way. You know, the first error you just bail out of and you're up, except without having to go through the rest. So that is the summary of the try and catch there. Now, the other option is, of course, unreachable. And catch unreachable basically says, this is never going to happen. You know, this is guaranteed. This is never going to actually err. And when you're running in debug, that unreachable will cause a panic if you actually hit it, and you'll get your stack trace. But if you're in release, it'll be undefined behavior. So use sparingly, or only when you're really, really sure.
YOLO.
Yeah, YOLO, exactly. You know, Zig, just trying to build on Z, there's quite a few, or C, there's quite a few places where they just say, hey, if this happens, it's undefined behavior. That's just the way it is. Now the defer. The defer runs code on a function return. And then there's also an error defer, which only runs code when an error returns. So if you're in the process of chaining up a bunch of options, you can do an error defer and then it'll pop out. Now I went with I didn't see a great example in the normal box, so I kind of went with one I've been playing with here a little bit. And you can kind of see how it works here. We're making something, a new struct here. We're doing an init here and an init here. And then immediately, you know, when the function exit, we want to de-init those. Same here with our library function. We're going to be doing some initting with something, and then right after that, defer free. And then that way, when we exit the program one way or the other, those are all going to, those allocations or those resource hangs will just automatically run. Yes, Amos.
So the defers you're declaring don't run until the end.
Yes.
Do they run in the order they're declared? Or
Inverse order.
Inverse order.
Yeah.
Okay.
So in this case, the file close will be run first. CSS free will be that, and then this is de-init, and then that de-init.
Okay.
So it makes sense to declare your defer as like, you know, right after the thing that you've just done and not like save. So that put it at the beginning of the function or at the end.
Yeah. I think the goal here is just basically as much as is reasonable, put them together so the programmer can see, okay, this memory is allocated and that this is taken care of.
The idea of defer is that if the program crash, the function crashes anywhere along the way, it will always be executed.
Yes, absolutely.
Wait for free.
Yes, or closing files and things like that too. Now here's just an example of the error defer. Right here, we're going to try to create that. Now we're doing an error defer. That way, if this errors, we're going to automatically clean up the device. But if we exit the function normally, then we're not going to clean up the device. There's a little caveat here that the error defer is only good for the block they're within. So don't use it in a loop unless you know exactly what you're doing. Yeah, if you have it up there and then you get out of that block, then the error defer is no longer active. So if this was in a block and there's an error down here, that error defer isn't gonna run on its own. So that's kind of thing of what I thought was really neat about Zig's error handling. Now, the other neat concept they have, which is not a new concept at all, many languages have these days, but that's the optionals. And that is the equivalent of the null value, essentially. Now, Zig certainly does have nulls in it because it interfaces with C, but it wants to be more comfortable with it. And to do that, you do the optional value. And this little question mark in front of any variable declaration means it's an optional value. And the easiest way to deal with an optional value is to wrap it in an if statement. And here's that capture again. I think that was the word I was looking for, capture. So we're going to do field, and if field is not null, we're going to capture that value as a pointer, which is going to be an any opaque. And then we can do the little pointer cast thing to it. Or if it is null, we can be down here and we're just going to say, screw it, just make it a zero length string. That's what this essentially is here is this is going to be an array slice of whatever is defined, and we're knitting it to a zero length. So yeah, basically if the pointer works great, we're going to get a string slice with what its value. And if it's null, we're just going to get a zero length slice in a nutshell. Any questions on this? I know there's a lot of funky symbols up there.
So Zig has pointers, I guess.
Yes, Zig has pointers, just like C.
References or something.
Yeah, they call it, yeah, it's pointers. It has pointer arithmetic and all that. They have a lot of this little built-in function and casting around it. You kind of, like I said, take some of the foot guns out of it. And that's exactly what this any opaque is. This value right here, question mark, pointer, any opaque is the equivalent of a C void pointer. Could be anything. And that's why we have to do this little magical dance right here to turn it into something we can actually use. In this case, it's
Why
like
did they not do it on the second pointer? Like the data's pointer is, it says pointer cast to CSV stream, but there's no like
So-
checking whether it's null.
this is code I wrote, and that's
Okay.
just being sloppy.
Okay.
You can get away with being sloppy in Zig. That's for dang sure.
Okay.
It doesn't actually make you do it. Now, the other thing right here that I haven't actually demonstrated here is there's also a dot question mark, which is the way of saying, I know, throw an exception if this is a null type of thing. And this, I'm not going to get the exception here. I'm clearly going to get it here.
Can you go over what Sean just said, that you do it instead of Sean? What is he calling out?
So he's calling out that this right here, this field's an any opaque type question mark, and that this data right here is an any opaque question mark. And
Okay.
here I did an if, and then did the capture here to make sure that I dealt with this appropriately.
Okay.
And here I'm just like YOLO.
Got it. Okay, so
Which makes a certain amount of sense. I mean, here I can handle a zero like string. Here, if my core data structure isn't there, then yeah, I might as well have a stack trace. But he's absolutely right. There's a better way to put that stack trace in there. And that would be a dot question mark here to say, okay, this is the equivalent of if capture else unreachable, which would do the same thing. And right here, yeah, and you can here we have another kind of try type thing, catch, except in this case, just return, just some unit variable, ignore it. We're moving off of life regardless. Okay, now why Zig? The bad. Documentation sucks. I mean, it literally, it's anti-documentation. You look at the documentation, you are going to get just done. Standard library is still evolving, and I'll get into that a little bit more, the immediate example I ran into. But yeah, and even when you're using it, you're kind of like, yeah, this is definitely still kind of a work in progress. Now there's consolations. The Zig help channel on Discord is, they answer the questions quickly. Generally turnaround time was under 5 minutes. Very friendly, good answers. I asked some really dumb questions. None of them pointed that out. That's always a plus in my book. Okay. Now, how to set up with Zig. I'm assuming most of you have ASDF installed, and that really is the way I prefer to do it. You just install the Zig handler, install the Zig, the 9.1 or whatever. And then the other call that I have is Elixir make. Elixir make is one of the dependencies you can get in there, and it runs make files while providing you all the magic include directories and lib directories for the Erlang header files and all that. And without further ado, let's go ahead and just sort of get into kind of the adventures we had. Showing some of this up here.
adventures.
Adventures. It was an adventure. Now, I'm not too sure. The whole setup was a lot different in my head when I thought we'd start going over some of this. So let's.
You blow that up about 9 times.
Yeah, no kidding. I can't even read
So
it.
is Zig specifically intended to work with Elixir?
No, it is intended to replace C.
Right, yeah, I heard that. I was just kind of surprised that the step there was create a new mix project.
Oh, I jumped ahead a little bit. I apologize for that. So the reason why I said create a new mix project right here is that in order to set up Zig to work with Elixir, the first thing I'm going to do actually is install with ASDF. The next thing I'm going to do is I'm going to create a new mix project, and then I'm going to add Elixir make to the whole mix.
Got it, okay.
But let's, I'm going to move my mouse. This is the part that gets kind of crazy here. Move the mouse cursor to the other screen right here. I actually want to introduce you guys to Ziggler real quickly, actually. And that was really, Ziggler is the thing that got me started on all this. But
You know, there's a guy named Zig Ziglar.
yes, yeah, I forget. Why don't you tell us who Zig Ziglar is, Alan?
He's a motivational speaker.
Okay, with applause.
Motivational speaker.
That was fantastic.
It's a lot.
He really gets the work done.
Look the same way with blank or No, I'll tell you.
Erling is named after a person, but
Yeah.
he had nothing to do with programming language.
Okay.
I think he belonged there before programming.
It was also a convenient coincidence that Ericsson language, can be abbreviated to Erlang.
Not much.
This is why I thought we should have scaled it.
Yeah, absolutely.
Command plus.
Yeah, let's try it. All right, so first I want to introduce everybody to Ziegler, and this is a library that was made by, what? I'm
Can you do
sorry.
that about 2 more times?
Sure.
We're really blind back here.
Ah,
There we
okay.
It looks fine to me.
So I'm not even going to try to pronounce his name. If you search on YouTube, he's got an interesting talk introducing Ziegler and the whole story that kind of went into making it. Just in a nutshell, you just do this. Def module, use Zig, you write your little elixirs, you write your little NIF right there, it goes out, it compiles it, and it runs lickety split. I mean, just
Oh, that's cool.
that, I thought that was really cool. Now, he did this was out, I discovered this at Zig 8 something.
Where's all the translation between?
We're gonna get
Elixir
there. We're gonna
values?
get there.
Okay.
No fear.
I was
We
like,
are gonna
does
cover
do that
this.
Automatically, because I'm in love.
Yes. Well, so the part of the story is that one of the reasons actually I wanted to give this talk is I discovered this about Elixir or Zig version 8. And I was like, this is awesome. This is cool. And I went to try this out, and on my Mac, it failed miserably. And a few other people were like, oh, it seems to work on the Linux. So I set up a little Docker machine, tried it out, and sure enough, it worked fine on Linux, didn't work on Mac. So I kind of started digging in to see what was going on. Needless to say, it was above my head. And then I was kind of like, well, I'll get around to it again too. And then 9.9 came out, and I did my little test again. 9.0 worked on the Mac. And I was like, fantastic, but not in Ziegler. So they did a lot of code changes or little language changes between 8 and 9. And in a nutshell, nothing compiled. So I volunteered to kind of give this talk in a way to kind of inspire myself to actually dig a little bit more into this and kind of dive in and see what can't be done to do it. And so, yes, we actually got Ziegler working on 9, not good enough for a PR yet, but good enough to demonstrate, which is fantastic. And we are going to start showing some of this. Lost my mouse cursor there, sorry. So right here, when you search for doing NIFs on Elixir, the first thing you run into is fast add. Yes. So one of the first things you run into is an example for fast add, which adds 2 integers.
Ooh.
Yes, really too. And so, Benchy, yeah, Benchy is a great little profiling tool. And I thought, what would be really cool is to just sort of like see how fast is fast add. So
Good ones are hard.
yep, don't worry, I ran through everything first. That doesn't mean I'm not going to screw it up, but right there you can kind of see that little output. Hey, that NIF got loaded. So we're going to benchmark fast add versus slow add. Fantastic. All right, no, yeah, no, yeah, of course you. And of course, fast add is way too fast for it to properly benchmark. But of course, slow add is way too fast for it to properly benchmark as well. So that's fantastic.
Put some sleeps in there.
I would kind of defeat the purpose to some degree, but I definitely was tempted.
But then you need to sleep with a number of
Okay.
seconds added by fast add.
So as we can see by here, slow add did 2 million instructions per second, and fast add did 1 million instructions per second, with fast add being 1.3 times slower than slow add. So clearly this is not the intended use case. And maybe fast add was the wrong name, but I was thinking, of course, it's just adding numbers. Computers add numbers all the time. In order to do a NIF, we have to do a lot of translation. So what else can we do here? And then we have,
Complex JSON manipulation.
There you go.
no, we decided not to go that route.
Okay.
We decided instead just to sum up a bunch of numbers. And I went ahead and used, for the fast add, we used fairly big numbers. I toned it down a little bit for the sum. We're just going to randomly sum up a bunch of stuff. See how that goes. And let's see if we get a different response here.
Fibonacci sequence.
That was, yeah, I was very tempted to do that, but for some reason I just had this written out first. And
What was the zero after the sum?
so Benchy puts out a lot of a huge struct / map type thing, and the semicolon 0 just means it's just an output of 0 instead of all that. So just think like that.
Yeah.
Okay, so now.
It's not like where you have to ask for the errors.
So now we got something a little bit more like NIFy. We know clearly fast sum did 56 million instructions per second. Slow sum only did 10 million, 5.3 times slower, and no little warning that, hey, we're doing this way too fast to properly benchmark. So there are definitely situations where a NIF might make sense to garner up performance.
I have learned that you should benchmark before saying something's fast.
I thought that was like the junior level type thing, right? First, make sure it's slow before you start to optimize it, and then make sure you benchmark so you know. Well, no, the first thing to do is to determine what will fix it, or what is acceptable. Once you got that down.
But even though you didn't do Fibonacci as an example, you can still recursively call these, right? Or
Well, to be honest, that was one of the reasons I shied away from Fibonacci. There's no reason to think that I would fail if I recursive, but this, I ran into quite a few little headbanging situations here and whatnot. I just, at this point, wanted to keep things really simple.
I didn't mean to distract you. Just curious if it was standing.
Yeah, theoretically, shouldn't be a problem at all. So I decided I wanted to do a slightly bigger project. And also I wanted to peel back the layers a little bit and see what was going on with how that translation goes. So the first thing we do, before I get too far, I want to show off Elixir Make real quick. It's not that, no, we're not doing it. This one doesn't do Elixir Make. So first I wanted to get an idea of where all the code that Ziegler does gets done. And they print it very nicely when they compile it. It might all be cached, so I might have to clear something. Yes. Yes, there we go. So we can see right there that it's printing out where it's putting all its code that it's generating. So we can go have a look here real quick. And this is the output directory it does. So you got the main file here, beam.zig. This thing is fantastic. If you want to write your own NIFs and you don't want to use Ziegler, by all means, go into his code and steal his beam.zig. This is all the zigified interface to the beam right here. You're creating the little allocator that works with the beam allocator. Go past all that. And then all these various things. Come on, keep going. It's not generated. This is handwritten stuff right here. Yes. We're bringing in our Erlang terms, giving them some sort of little same places and terms and identifying them. And then we have these get functions, which comfortably get the value that's passed into your NIF and turns it into a Ziggy type value. With my favorite being the make slice, where a slice in this case is a string that contains its own length, so you don't have to deal with that stupid null pointed or zero terminated strings, which are great until they're not. Floats, 64s, things like that, all already nicely written for us. I did not get into really using resources or yielding, but there's plenty of code in there to do that. I haven't actually proofed it out to see if it's saying yet. So right there, but the more interesting thing we're going to need to look at here is what did they generate? Now, this is a file that comes included. I think this file is included. Erl NIF is just the way they suck in the header file. This is a nice little format here. You do the C import, which is a built-in Zig function. It basically turns the header file into something Zig can use. And then we do this using namespace right here, which essentially puts all this into the same namespace. Now with 9.0, they made a slight change to using namespace in that within this spot itself, C import E is its own namespace, as you can see right here with that E. So I'm probably getting esoteric. Sorry, but in the nutshell, when you put a using namespace, you're not doing it for that file. You're doing it to group whatever is in there into its own namespace. So when we include this file from somewhere else, this import and that real NIF term are going to be at the same namespace level. Probably just confused you all. Don't worry about it. It makes perfect sense when you actually do it. Okay. So, yeah, neither do I. That's why I shut up. Okay. So this is the code that's actually generated for the NIF. So the first thing you write here, you're going to recognize our fast add right here. You're going to recognize our fast sum right there. Yeah, nothing, yeah, exactly as it appeared in our program. Now, then there's these shims, and these shims are how we are going to, or how Elixir and Zig interact. And these are dynamically done. They were created when the thing is compiled. If you notice that fast add shim, we start with the value of I60. Oh, that's so fast. We got the I64, which is an integer 64, and return an integer 64. Right here, beam get I64 with a catch and return a function error clause. That doesn't work. Get the second argv, make it an I64. That doesn't work. Return a function error clause. Get the call the actual function that we wrote, and then in the end, take that result, make it into a 64 and return it. So
Can you humor me with something?
absolutely.
Can you show me an error if you pass in the wrong type? Like if you pass in Jeremy for the int bad.
Let's find out.
I just know that in NIFs sometimes the error when you pass in the wrong thing, it's just like, yeah, it sucks to be you.
Oh, I got plenty of those, but I think you're
in the
right.
rough- You're in that temp directory.
Oh, yeah, okay.
You CD dash, yeah.
CD dash,
Yeah.
like that?
Yep.
Dude,
And
that's
that-
awesome.
It's like a swap though. It doesn't keep going up.
Okay. Yeah, I did not know about that. Yeah. I
Right.
had a piece of paper, I'd write it down. I'm gonna forget by the time I leave. But no, okay. So, yes. Hey, dude, that'd be awesome. Okay. Huh? Let's go. All right, there we go. That's one. And, nice. Very elixir air, no function calls passed in fast add, following character scale, one Jeremy, type of function calls is blank and blank. Well,
So,
can't have it all.
I
Yeah,
didn't know if it would know like what the type should be or not. So
no.
it's not.
You know,
horrible.
that might be a nice patch to Ziegler. That should be an argument error, not a function clause error.
Fair.
Yeah, put that in Slack too. Yeah, I mean, yeah, it does. I mean, it does a pretty good job parsing this out. This part right here actually is required. It's the direction to say, hey, this is the NIF name of the function and it's a singularity. And there's a few other things. If you want a yielding NIF, you put yield there. There's a few other options. Dirty, I think dirty is one of the options for doing NIFs. I mean, yeah, it was, I mean.
Is that why it has the dirty, is that why it has the no suspend?
Possibly. I did not dig in enough to actually find out.
And does this suffer from all the same problems with NIFs?
By the whereas like if you don't do it right, you're going to crash your whole program. All those Elixir uptime guarantees freaking out the window. Absolutely.
If
Um,
you go to sleep for 3 days.
Yeah, I should have set something like that up to sleep for 5 seconds, just see what happened. Yeah. Mhm.
Dirty is your-
Yeah, if you put dirty on that, it'll
Yeah, you could just hold the dirty scheduler forever.
Mhm.
Yeah, I guess you run over it.
So,
Just don't use up all your dirty schedulers with your evil sleep function.
all right, so back to the kind of parsing what they did here, and then we'll get on to the next step here. So yeah, they make these little shims that just translate the arguments nicely and back out again. And then some boilerplate Earl NIF func type stuff, the name of that function, the entry point of the function, arity to match it up, and basic bit. It's all pretty straightforward, and a NIF in it that doesn't actually do much. All right, any questions before we move on to the next phase?
What?
Hmm.
Trying to think of like, if it's not doing it, is there anything else that it?
You might allocate resources in
Okay,
it.
okay.
Yeah, and then when we're playing around with the resource type thing, if you're going to initialize a resource, which in this case means set aside a chunk of memory that you'll get a pointer to that you can use between NIF calls that they pass in. This is the spot where you'd kind of set all that up. And the resources, when you set it up, you basically include a destructor function so that you can clean up all your memory once the garbage collector says, hey, we're done here. Yeah, yeah. So it's the C way of deferring. Yeah.
Is that also you control with that, sort of comment based, when you write your Zig,
Your total
the
Zig.
comments of in your Elixir code, can you manipulate like your NIF function in there?
I didn't see that directly, but I think there'd be some indirect thing of your NIF in it.
Otherwise, yeah, come into this generated folder and change stuff.
I think at that point, you just leave Ziegler behind, to be honest with you. Or the other thing you could probably do is, yeah, I don't know. I didn't go into that much because actually, to be honest with you, I did a little bit of Ziegler. Like, okay, well, makes this thing tick. So
Don't spend too much time trying to answer the question if somebody doesn't know what's actually asking.
yeah, I know the feeling. If I knew what I was talking about, I can answer it, but I don't. So the next step I did was to make this or make a project without Ziegler because I thought that would be really neat. Do I have it up or do I need to bring it up? What do we got here?
Without Ziegler and without Elixir? or-
Oh, no, that would be silly. This is an Elixir user group. Okay, that's fast.
Ultimately, is it C code that's being executed though? I mean.
No, Zig wants to replace C, not
Right.
transpile to it.
Okay.
So let me get to the right. Yeah, they were very explicit about that in the little reading and the motivation and whatnot. They don't want to just be, they can generate C code, but the real goal is to drop Zig into an existing C project and just replace your CC with Zig and start taking over the code base that way.
That's a bold goal, Cotton.
Yeah, it's completely unrealistic. But hey,
It's still worse than the Rust stuff. So, like,
Yeah.
rewrite everything in Rust.
You know, rewrite the next one.
so
They have Rust, modules for the
I know.
kernel now.
I know, I really wish that old school Linus Torvalds had answered the question whenever they asked about rewriting Linux and Rust instead of new school Torvalds.
he's older and trying to get into heaven now.
Yeah.
All right, so
When he made you
now I work at a large legacy company, shall we say, PepsiCo. They don't really embrace the information age very much. And so I find a lot of my time involves dealing with CSV files. So when coming up with a raison d'etre for this project, I was kind of like, well, let's parse CSV files since I seem to do that more than I'd like. So I looked online for, there's a great awesome C. If this pulls up. Awesome C, search through there for CSV. Sure enough, structured file processing, CSV files. There's a C library for that. So I decided I was going to learn how to use that in Zig. Ooh, fantastic. I'm not entirely sure I'd want to throw my stuff at that at this point. So what I started out with is I made a project, Mix New, and I immediately threw in Elixir Make and I made a makefile. And Zig comes with its own nice build system. There's Zig build in it. It's a build file, which is also written in Zig. It looked kind of esoteric and scary to me. And I know from dealing with the other stuff I dealt with that Zig also handles a single file very well. So instead, I put the root source file up there in my makefile for Zig source files. And then everything I need from that CSV shim is included in there. And so Zig just automatically finds it when it starts compiling. So instead of going with the Zig build and a build file and a directory and all that, I just have that one file. And in my makefile, I do a Zig build lib, my source files, taking advantage of the variables that are passed in by Elixir make to find my dash include, my runtime include directory, dash I, the place I need to get my CSVH over there. And then those libs I'm going to be interfacing to, which are going to be the URL interface libs area, as well as the libs I included. When I did briefly try to switch this to a build Zig file, I kind of stumbled at finding a way to get those included in with it, just from the environment variable. I'm sure there's an easy way. I had other things to do, so I just went back to this right away since it was already working. Now, if you're wondering how come I have a Linux one here and a DAR one here for the Elixir, that's because that was kind of a legacy when I was testing around with 8.0. I just basically cargo culted my makefile for when I was playing around with that. There is a top level directory here that has the Docker and the thing. So if I wanted to run this in Linux, I kind of set it up that way, just in case I started to run into problems, I could just, run it in Linux to see if the problem was still there. And if it's in both places, then it's me. And if it's only in one, then, it's clearly kind of a system issue I need to dig into or not. But never needed to use that. So fantastic. Just explanation there. When launching on the project there, let's talk about basic structure of our Elixir CSV here. Oh, no, sorry, that's the Elixir CSV file, or the Elixir CSV library I use all the time. I'm going to get it together for benchmarking. Here is what it basically looks like when you're going to do all the NIF loading yourself. You have a module, you use the onload here to call load NIFs, which is another function right here where we just do Erlang, load NIF, and a path to your shared object that got compiled. If we go back to the makefile, you can see after we do our compilation, we move the result of the compilation to a place where we want it, which in this case, we just put it in priv. When you compile on a Mac, it gets the dilib suffix. When you compile on Linux, it gets the SL suffix. Or Elixir wants it to have the SL suffix, so we just compile it or just move it to the SL suffix, and then it seems to be happy. And then you stub in your programs that or the functions that you're going to use to call into the NIF. Within them, you raise NIF CSV not implemented. And that means what happens then is when you load this module, the onload gets called, Erlang loads your NIFs, and you call this function. And if the NIFs did not load, it's going to raise an error. And if they did load, it's Zig. It'll probably raise an error the first couple of times anyway, but it'll be a whole different error. Any questions at this point?
Why did you not use Erlang NIF error?
Yeah, go and put that in Slack.
Dun,
Yeah. I was cargo culting something else, probably CK stuff.
NIF errors far more.
So then, yes, I hijacked the beam.zig from the Ziegler project, just copied over the pieces that I was interested in, so I kind of get a better idea of what was actually required. We ended up with just an allocator, the make slice, which is basically take a C string with a null terminated character and turn it into a Zig slice, which is a string of bytes plus the length, and some bounds checking around it, so you don't accidentally do something silly. So yeah, just those little bits right there. I made my own little CSV shim. We start out by bringing in the beam Zig thing, we'll call it NIF. The CSV file, which is where the bulk of the CSV parsing is going to be there. And then I was playing around with resources, never got it working right, and I'll get to that story here in a little bit. But yeah, CSV shim right there, raise function clause error. If we don't have one argument, turn it into a char slice. Once again, we get that C null terminated string and turn it into something with bounds and automatic length and just general over good. Call our CSV function and take the result of the length, turn it into C size, and use the NIF make list from array on our output to turn it into a map for the row that comes back. And we'll get to that in a little more detail. The other call out of here that you haven't seen yet is the environment here, and we pass it in. The environment is passed into your NIF. It's what you use to create objects that you're going to be turning back into Erlang. So atoms, maps, lists, all those things are going to be requiring the environment to actually make them. So this is our entry point right here, csv.csv. So let's go to csv.zig. Okay. So once again, including stuff. Key part right here, you've seen it before, where we see import instead of just import, see import the csv.h. That brings that header file into the Zig namespace so we can use it. We are going to be holding on to a certain amount of information as we go through and process the CSV file. That's what this is here for. The CSV thing processes the CSV file line by line. It does not store anything. It just gives you like, hey, this is the field I just read. Hey, here's another field I just read. Oh, hey, I read a row. So we're going to keep track of the fields we've seen and the rows we've seen in this little thing right up here. Callbacks, it does it all through callbacks. This is the callback we use when we're parsing out the header. This header row signals that, hey, we're done processing the first row. And then fields and fields row are for the rest of the thing. Once we process the header separately, we're going to process the field or each field separately. We just sort of assumed every CSV we're going to get has a header and is relatively free of errors. Well, not relatively, is free of errors and will give us back good stuff. So here's the entry point right here into the main thing. So first thing we do is the CF lib is going to require this parser. CSV lib is anything on, it's the namespace that contains that C import, that header file. So it, it namespaces anything we're dealing with there. So we got instructions for a thing. We set it to undefined. Undefined is the way to say, hey, I'm not going to initialize this value now. If you blatantly try to use that undefined, the compiler will flag you. If you try to work around the compiler, it's super easy to do. Yes, you have to define it with something. And the way you say, hey, I'm not going to give it a value right now is undefined.
Is this like in this case, just putting the slot on the stack for that variable, but not initializing it?
Yes, it is essentially putting the slot and not
So
initializing.
it's not implemented on covers, it's one that's optional.
No, it's not optional. It's just, it's literally undefined. And then we're going to initialize our struct here, which is your basic thing right there. Once again, all the fields have to be initialized or set to undefined. In this case, we're hitting them all, field count 0. We're going to use an array list to keep track of the headers, the fields, and the final result. So we're going to build it all in memory. An array list is just your basic resizable array. Once again, you know we're allocating memory because we're having to use an allocator. So when we call init here and we pass it an allocator, that is the thing that's going to be allocating the memory. In this case, it is the beam allocator. So each one of these is actually going to be a call to enif alloc. And when we free, it'll be a call to enif free. I'm not too sure, Sean, you may know, can you do regular malloc and calloc calls in an if?
Yes, but then the Erlang runtime can't track
So
the
if you're going to free it within that NIF call, then it's probably okay.
Yeah, but then it would be on the stack. Unless you have to put it on the heap. But
Okay.
just regardless, it's generally best to not try to mix allocators.
Okay, I think the Zig thing would probably agree with you on that entirely. Yeah, and when you're designing a library in Zig, they really stress that if you allocate memory, don't reach out to global space, pass in an allocator. It gives you a lot of testing options. They have a failing test allocator that will fail memory calls at your instruction. And they also have a standard testing allocator, which does memory leak detection and things like that. So definitely, if you allocate memory, you can pass in an allocator. Obviously, we don't do that here. We just reach onto the global namespace. Yeah, it is what it is.
Why not?
Yeah, yeah. So right here, they have the example of the defer. So we init right here, we de-init right here, we init right here, we de-init right here. We're actually passing that one back, so I'm not de-initting it at all. We'd have to actually do that after we converted it, everything there to the map. It's just not done. Just setting up the options for the CSV library. I can show you the documentation for the CSV library, but just rest assured, you start out with an init. You pass it the address of your parser variable there that it's going to do to kind of keep track of things internally, your options, which are nothing, and then defer CSV free. So when we're done, it'll automatically free that for us. Open up the file we're going to be reading and immediately defer close. So at the end, it'll automatically close it for us. We'll come back to buffered readers and the actual reader a little bit later and what a pain in the butt they are. But this is this was the kind of the standard practice and practices at the beginning. So that like Zig Learn that gives you standard patterns and practices. That place was the invaluable in terms of learning how to use the array list and how to use these readers because documentation sucks. Without that little pattern practice, I wouldn't have been able to figure this out without asking somebody on Discord. So we're using this little, so now we got a buffered reader. We're going to read until the delimited or \n, and then we're going to call our CSV parse function. This is going to do with the callbacks of the header and the header row there. Those are the callbacks we defined up above, saying, hey, whenever I get a field, we're going to put it in the header bucket, and we're going to stop when we hit the header row. Well, we're not going to stop. We're going to set rows greater than 1 right here, and then we're just going to break. On to the next bit, and then we're going to read the next line of data, and this is that capture again. So while we read this, we then capture that value right here. We can use it. If it is, this is that unwrapping for the optional type here. If it's not null, we capture that line here. We can parse it. See if the parse does return it returns the ASCII value of the last character that it read that broke on the line. We don't care, so we have to toss it away in the underlying syntax there. And once again, the fields is the callback to handle the fields, the rows is the callback. We just keep going. If we get a line we don't know about, we're just going to break and continue. Be done. That's how it's.
Why did you try the first while loop and not the second?
I forget exactly. Keep in mind, some of this is me playing around.
It was deliberate.
Yeah, so I had to try here at one time. I think I was getting guffed by the way InStream was working and try to figure it out. So this is the shortcut way that this all worked. I think if I recall, actually, I was trying to figure out how come something wasn't working quite right. And so I wanted to print the error right here. And net result was, it was my misunderstanding. I never actually got down to this error and printed it out. So I knew it wasn't actually error happening. I think what it was I was getting a null line of data. And now I know, hey, I need to break out of the while loop and be done. So it's just an artifact of me exploring around.
So is this else in the like Elixir after since kind of thing? Like what is a while else?
So this is actually an if, so this is because of the error. So we right here, we do the match on the line of data if it's an optional, or if we get a line of data, we get right here. However, if this returns an error, then we go into the else. So
Doesn't
it's
Elixir have some similar construct? I haven't worked with Elixir in a while. Doesn't Elixir have an else clause?
with else, yeah.
Maybe.
Yeah,
That feels like a little bit else.
yeah, this only compiles correctly if this value returns an error. You can't use it except in that. And then, yeah, capture the error, print it out.
Okay.
Yeah, and then we finalize. This is the way you tell the CSV processor library that you're done. It'll call the callbacks any last times it needs to. Finish that up right there. And then we return that array list we created with all the items that were built up from calling thing.
Okay.
And then back to the shim. Right here, we got the items. The items is so in my mind, I passed it 2 things to make the list from the array. Oh, nope. Okay. Sorry, this is actually just making a list from those items of the results. It's up here in our row callback right here. So the rows gets called once we get all the fields from the thing. We get the maps, so we get the data structure that we've been passing around, increment the rows by 1. We look at the size of our headers and the number of fields we got this term and take the minimum of that and call that our map size. We then initialize a new map, and then we call NIF make map from arrays. We're passing in the headers, we're passing in the fields, and boom, magic map with the headers as the key and the fields as the value. And this dot pointer is just a safe way to unwrap the items slice. The slice itself is the pointer plus the size. The pointer, just the pointer right there, is the raw pointer by itself. And we are passing in the size right here, which is the min of both, so we know we're not going to be accessing bad memory. And then passing the address map that gets built. We pass that map on to the end, and at the end of the whole thing, back to CSV shim.
Is the
Sorry.
underscore in there? Is that just ignoring?
Return value.
Yeah, yeah, underscore equals after the,
Yes, that is ignore the return value.
okay.
So real briefly, pet peeve, when Zig went to 9 and said, hey, you have to use underscore to make a value don't ignore, they don't mean underscore variable, they mean underscore. You lose all context, whatever, that was a real pain in the ass to just
Oh,
sort
so
of,
it has to just be a plain underscore.
it has to be a plain, yeah. Yeah, they wanted to do that to kind of really say, don't have unnamed variables, don't throw away values.
Can't give a meaningful.
You can't document what you're throwing away.
Yeah, which that was very frustrating for me. And that was not the case in 8. That was part of a thing that transferred to 9. Keep in mind, this isn't a 1.0 yet. They might see wisdom and allow you to at least put,
If they
it's,
want to replace C name.
yeah, I don't know.
Go people like to name their constants with leading underscores.
Yeah,
That's so weird.
and I found it really annoying because I was flailing around a lot. I don't know what I'm doing with this thing. And so, all of a sudden I'm not using a variable and my thing won't compile. I mean, I wanted a warning. I don't mind a warning or two when I'm flailing around, but to actually stop me from progressing, I have to go, I stopped using a local here and now I have to go change it to an underscore, delete it. And, I might need it again shortly. It was incredibly frustrating. Okay, bent over. So yes, we built up our map. We got a list, we got an array list of a map, go back to our shim. Enif make list from array. We can now pass it back to our CSV function, and this will return the map. So let's go ahead and
Ooh, benchmark.
oh, we'll get there. We'll get there. Don't worry. Mixed test. We're going to start with mixed test here real quickly. So we just build it, we compile it all. Yeah, I'm definitely. Oh yeah, hey, I didn't actually fix that bit. So I was going to get into something. Yeah, segmentation. Notice how we're just sort of done. I mean, hey, we're doing stuff, we're printing stuff out. Any idea, did any test work? Who knows? It just stopped. Just boom, crash, done.
I like a good side fault.
Yeah, you probably have, if we've been dealing with Elixir, we haven't got to see a seg fault in years until we start doing this. So, yeah, we'll just, that's probably not the way we'll do it here. Let's just go, we'll copy it in from benchmark so we can just sort of see it right here.
Or if
Yeah,
you use
run
it,
dial right there.
yeah, if you don't use the value to return, it might convey it, so you can do underscore both.
What am I doing? There's no one
So
page
you're
here.
explicitly saying.
I was like, you made a UI for this puppy?
Dude, if I had had the,
Well,
if I was fast enough, I would have, but
Yeah, if you're, if you're Jason's not here, I'd like to see him reason that using Zig for all the mathematical stuff.
so yeah, Ziegler actually, when it packaged, someone almost immediately did that and made a Phoenix live view ray tracer with it. I didn't actually pull that up, but yeah, absolutely, super cool. So as you can see, we're, I think so, yeah. I'll have to look at that. But yeah, when you go home and Google Ziegler, you see if there's like a Ziegler ray tracer in there or something like that. So yeah, you can see we're basically just parsing the data just fine there. Right now, we'll show you the one using the Elixir library. And already you can tell there's a difference right here. One is that it's checking each line individually. So our version obviously doesn't do some of the things that the Elixir one is doing. But then again, when it comes to CSV, how can you really tell when you're at the end of line with a malformed CSV? It's a hard rule. So, but yeah, that could both work too. So yeah, let's get to the benchmark here. So we started out with just a small file. And we're curious which one of these or what the difference of performance is going to be. So let's.
Pretty cool.
Oh, forgot to do the semicolon 0 so we could ditch the output.
Share that with the
Yeah, this is
Every answer is like extremely.
I wish it had told me what the memory usage was, because the Zig one or the CSV one's a streaming implementation already. So as you can see, we're actually got some pretty decent improvements going on here. So the Zig version does 2,000 instructions per second, and our standard native Elixir version does only 0.7. So yeah, 3 times slower than the CSV thing. So that's a pretty significant speed up right there. Now, one of the downsides is, of course, is that we are doing it all in memory, while the Elixir one is a streaming. And what I wanted to get to is I did attempt to get a streaming one going using resources and whatnot here before coming to this presentation. But failed miserably. And one of the reasons I failed miserably was that right here, where we get into those buffered reader type things. So right here, we get a file. We then use that file to open the buffered reader. And then we use this to open up the stream. Now, what you don't see here is that essentially captures this value, which is a local variable within the stream here. So when you attempt to serialize it out into a resource, and it gets back, it's now pointing at invalid memory. And you got some garbage, or it crashed, or it's whatnot. So Zig certainly lets you do some stupid things. So it does take away a lot of those foot guns that C has. It certainly leaves plenty of ammo in the barrel, so to speak. So yeah, that was very frustrating because yeah, I was hoping to be able to show that too. But nope, never got
Would the
that.
solution there be like allocating that on the heap as a pointer?
So I did try allocating things on the heap, and I did try mem copying too, using some of that comp time type stuff, just a generic memory copy. I don't know why that didn't work. I expected it to, but it didn't.
Because like I look at that problem and I go, oh yeah, the Rust compiler complained about that.
Yeah.
Right? Like you're trying to use something mutably as well as immutably at the same time, or this thing is the lifetimes don't run out or something. But why?
Well, you know, actually, that's a great little segue. So one of the things I kind of got that tripped my interest about Zig versus Rust, because one of the questions is why Zig when there's already Rust and whatnot. And I think as Jordan, who worked with me at CK, can tell you is that when you're dealing with NIFs or something like that, you write them intensively for a week, a few days, maybe 2, and then you forget about them until something stops working, and then you have to dive back in. Yeah. And Rust is not a language you forget about after 2 weeks of work and then dive back into and just pick up. So I was really kind of thinking, hey, something super simple that you can kind of remember that isn't going to be terribly complicated would be fantastic for something like this. And to some degree, yeah, I mean, I've certainly gotten a lot farther with Zig than I ever have with Rust, but at the same time, it definitely has its own idiosyncrasies like anything else. Let's just say it's not quite as simple as I was hoping it would be, but maybe my expectations are just a bit high. All right, so yes, we did that one thing. I kind of explained the stream and how you can kind of shoot yourself in the foot if you really want to here by passing back addresses of local variables or somehow them just sort of getting wrapped up. And I really think this is kind of a problem with the standard library approach to reading because it really is just a file handle on the other side. We really shouldn't be somehow capturing from that little bit, capturing some local variable and passing it back. Okay, so you know, we did this little test with our little test data here, which is a relatively small file. Turns out there's some really big CSV files out there on the internet. So I went and grabbed some data, census data from New Zealand, and decided to try to run that through to see how fast or slow it was. And it turns out that was be really boring as we sat here for 15 minutes wanting to go. So I pared it down into this big test right here. So we can just sort of see if it holds true while dealing with large data sets as well.
This one's only 14 minutes.
Yeah, that's kind of what I heard Zig describe as before, a subset of C almost.
Yeah.
Stuff fixed.
Yeah, a lot of the, taking away a lot of the kind of like, oops, you know, if we, that turned out to be a bad idea. Null values, you know, null terminated arrays. You still have null, they call them sentinel terminated arrays in Zig, but they had a little safety around it.
Yeah, to get back to the point about easy language, we can come back and figure it out.
Yeah. Yeah.
Zig gives you bullets and gun it, and it's unsafe.
Although I would be curious to know more about the comp plan stuff you're talking about, because that sort of sounds a little bit like C++.
Yes, there's definitely some of that going on. I've seen that compilation before. I looked at, there's some good stuff on it. By all means, Google it. I kind of got it. It's the way it does generics, kind of like you say with that template type thing. Seemed neat. I just kept expecting it to work a little differently than it actually does. So that was kind of an impediment for me. Yeah, 7 times slower. So wow, that's a pretty significant difference when you start getting over bigger data sets. Now, one other thought I had at this time, and that is that we recently introduced a JIT. So I was super curious how things compared with the 23 versus the 24 in terms of this. So I moved all of that stuff we just did to OTP 23 and set up a little shell script here to first run it on OTP 24 and then OTP 23, and hopefully it'll continue to work. So let's start with the sums. First, we're going to do it for the OTP 24. And that's the one with the JIT.
Yeah. 12 times slower on 23
And
and 4 times slower on 24.
so that's a no.
Or
no.
the slow was faster.
Yeah, the slow sum. What do we got here? We got 4 for slow sum on
I had
4 million instructions per second versus 12. So considerably faster on the JIT, but still slower than the
That's not legit.
yeah, but still slower. Oh, yeah, sorry. Still slower than the Zig, but yeah, significant performance improvement between 23 and 24 for this math intensive operation. All right, and then the next one is RCSPs.
You gotta put forward in your around those gym versions like the people here.
Yeah, you're fine. So just remember the JIT was the 4.5 or 0.45 instructions per second. 1,000 instructions per second. Right?
Is that actually loading the NIF the first time it runs the Zig function?
I think so, yeah. Well, when the module loads, that's when the NIF gets loaded.
Okay, because you might want to put that before you start the benchmark, make sure it's loaded.
Wait.
Good thought.
Okay.
Although Benchy, I think, does a warm up.
Okay.
It does, yeah.
So Zig was slower on 24 on CSV.
No,
No,
about the same. 131 versus 132. The Elixir version was 0.45 on the JIT and 0.32. So even then, a decent performance bump. Cool. That's pretty much what I got
Nice.
for. Oops. I think I have a slide to our left here. Yep, how to set up for Zig. Finally, what you want to use it for, you can go to Awesome C, find some C libraries you want to play. I think they got an audio processing one. They got a few others that are just sort of fun to play with there.
Sport vector machines.
Yeah,
Yeah, this would have been awesome back in like 2016.
Yeah, that's
Stuff
exactly
like
what I
credit
thought.
card readers.
the one thing I was trying to remember, what did we write zip NIFs for? I think you did one for rank 1, but I think everything else was ports, wasn't it?
I don't remember exactly details. The bill reader was the interface one.
Yeah,
And then,
That was one you presented.
I'm pretty sure the credit card reader was maybe this.
okay.
But yeah, maybe it was a C program that we wrote.
How about the RFID one? The RFID reader. I think that was definitely C to some degree
That
because
was
I
definitely very that one.
Yeah.
Probably. Maybe that was one else. Maybe the credit card.
You have a question? This is probably what I should have done in the first place. I guess for point of reference with Zig, C and whatnot, what's like a application? How would you be applying this? Like, is this like for an embedded systems thing?
it can be for embedded systems. The hardware, if you have to interface with hardware for some reason, you go to that. I think nerves would definitely have a position or for something around in there. More than that, just sort of playing around, to be honest with you. I think CK is the only place we've really seen this stuff in production.
Well, this awesome C thing right here, like there is billions of lines of C code to do like everything you actually want to do. But in like libraries, but interfacing with those libraries from Elixir can be, somewhat painful.
Mhm.
Sometimes you do this stuff for performance reasons. Like, so Elixir Erlang, they run on a virtual machine. So you have like a machine above like the real hardware.
Yeah.
And your C and stuff like that runs on the hardware. And so C and Zig, things like this, there's optimizations that you can make that you're not going to be able to get from the VM. Because the VM controls a lot of how things run. When we get to C, you control how everything runs to a point. It's not, you're not writing.
Who should have you on fire accident?
Yeah. Yes.
It's a bigger conversation that I'm interested in. It spans.
Well, if you need something to be really fast, you might want to do this. Like if you can't get the performance that you want out of Elixir, this is a good place to go.
Probably
Or
don't need it
interfacing
for
with
web
web
apps, but so you probably don't need it for much like web apps or whatever.
Yeah.
Well, did Postgres, didn't Ben do something with just
Yeah,
JSON parsing and Rust for?
yeah,
quick
he
bump?
used the Rust JSON library and wrote a binding in with the Rustler, which is similar name to the Ziggler library.
It doesn't have a cute little sigil in there just to embed it right there in your
No,
code.
no, it doesn't. You kind of have to.
And if you know Rust.
Yeah. Yeah.
He wasn't really doing it for speed reasons. He was doing it
For memory usage.
waste and memory usage.
Yeah, because we were making like megabytes of JSON on each request, and that was causing a lot of garbage because of the way that things libraries like JSON or Jiffy or whatever create terms. They don't share any memory, so they were always copied because they were smaller. They tended to be smaller than the 64 bytes that are required to go onto the binary shared heap. So doing it in Rust meant that like all of those things that went across, say like these are the names of the keys in the JSON object, those didn't have to be copied. They could just be referred to and turned into a write V, basically. But Saturday is really awesome technology. But you could do something similar with Zig if they've got a nice JSON library. No reason why you wouldn't be able to.
Yeah. Yeah, the problem with JSON is you can't stream it. CSV can be streamed. That
Yep.
is kind of cool. I was just thinking about that. It's not new and fancy or anything, but at least you can stream it. And you can deal with gigabyte CSV files and still process them without exploding in memory. Just wanted to also do a quick plug for this tool that someone else introduced me to. It's called Pan
All right, sorry, folks. Jeremy's computer just died,
yeah,
but we're still on.
it's a work computer, don't worry about it. No. So I just wanted to just show that Pandoc can turn markdown files into that little Reveal.js presentation. I loved it. I just thought I'd share it with folks real quick. It's a cool way to go if you need to make up some slides.
Cool, that was very interesting.
I actually have a question for all the expertise in the room here. Out of memory, K8s and Elixir and the way Elixir or the Beam does garbage collection on a cluster. It doesn't make sense to me that the darn thing is going to get killed by K8s before it actually triggers a garbage collection, a general garbage collection. Am I making any sense with that question? That normally, or the Beam, it garbage collects when a process dies, it garbage collects that process memory, and it doesn't do any other garbage collection until it runs out of memory, at which point then it'll cycle a garbage collection thing and clean some stuff up. And it seems like we got, K8s pods out there dying.
They do a lot of stuff with big binaries.
Yeah, there's stuff with binaries that are
I was
happening.
gonna say, as you were talking about stuff with Zig or C and Schumer was thinking next to CK, and we had that big query stuff that was getting killed a lot.
Sure, it's very
Yeah,
acceptable.
My experience, and maybe you remember, Alan, too, but generally you give it enough headroom on your resource requests on Kubernetes so that it doesn't get killed. And then if you have to make it like in a tighter space, you can up the interval, or rather decrease the interval, which it does full sweep.
Okay,
That's not going to help you if most of your RAM is used in the binary shared heap.
okay,
Because if it's shared among multiple processes, then it's not going to get garbage collected until all those processes that have a reference to it die.
okay.
Or lose or drop the reference.
Well, to be fair, I think we're just building that binary crap up in a particular process. And the right solution is probably just to have that process die. Well, use IO list and then have that process die, but we're still running into, there's some very data intensive things that happen. They generally happen within process, and every now and then, yeah, pops.
Yeah, it's pretty brutal because it's designed to be fair, even in the case of things that might be behaving badly.
Okay.
So like it's going to go, well, you're over memory, and that's actually probably more the Linux killer than Kubernetes specifically.
Okay.
But it's going to shoot that process in the head if it goes over.
Done. Okay. Well, yeah, it seems like it's going along fine. Like it should be garbage collecting. There's probably stuff to collect. And oh yeah, actually I know there's stuff to collect. It's well run it on itself and memory will just drop.
I forget how we can force it.
Yeah, you can suggest a GC, I think, but you can also do full sweep after, set that environment variable, or set it in the roll flags.
Okay, that feels better than just having a cron process that occasionally kicks off and does a sweep for you.
Yeah, the
Feels
bad thing
good.
about full sweep after is that you set it too low, you're going to spend a ton of time, or it's going to spend a ton of time trying to find things to garbage collect instead of doing the work. So it was like a trade-off there.
Gotcha.
It's not quite as crazy as tuning a Java virtual machine, but it's getting up there with some of that stuff.
Yeah, I can kind of echo that a little bit too I remember doing container optimization, and I don't know if you're running into this, but I know it can be tempting to want to do bin packing and try to crunch as many containers with as small as memory as you possibly can onto a system. But those containers really like to breathe and have a good chunk of headroom for memory. So if it's possible to do that, not even just in Elixir, but just in general for containers, the system will probably run better.
Cool, thanks.
So I'm in a better position than I am right now. I'm spinning up a Rails process per switch in a rack, and there's two switches in a rack. And, yeah, there might be hardware.
Gosh.
and stuff, so, yeah.
We feel for you.
Actually, that was another question I had. Do Ruby guys try to get another pair language going? Or as kind of a little hobby thing off on the side, the way Elixir programmers tend to do like a C or a Zig or a Rust or.
I feel like
Then-
the pair numbers see interrupt things.
Mhm.
I don't know about that. I don't spend that much time paying attention to it.
First time I saw a Rust presentation was at Seattle Ruby, Seattle
Okay.
RB, so.
First time I saw a Rust presentation was St. Louis Ruby.
And lots of Ruby people did Elixir, so that's how I got into it.
Okay, you did Rust presentation.